ARC-NAV co-produces knowledge with local and indigenous communities in Beringia, a region of the Arctic encompassing U.S. and Russian territory that is expected to experience some of the highest variability in sea ice conditions in the coming century. Observing and modeling sea ice, we forecast hotspots of variability and work with communities to understand socially relevant sea ice change. We document diverse narratives and critical policy challenges to explore how these flow through the governance networks from the local to the supranational. With communities and regional stakeholders, we explore the robustness, vulnerability trade-offs associated with changing sea ice dynamics. We acknowledge self-determination of each community and partner through establishment of memorandums of understanding. Partners and communities help us to set the research agenda, co-produce models with us, and work with us to create useful scientific products focused on adaptation.
My name is Tatiana Digay. I am Itelman from Kamchatka. And a PI on ARC-NAV project. It's a great pleasure to be working with such an interdisciplinary team of scholars and indigenous knowledge holders looking at the adaptation to sea ice variability across the Bering Strait.
The Arctic Ocean is transitioning from perennial sea ice cover to a seasonal sea ice cover. What we see in pink here is a typical minimum sea ice extent in September in the 80s and in the 90s. In white, what we see is a typical sea ice extent of recent years, like starting in 2007. What we see is that the Pacific sector of the Arctic is completely open and without sea ice. If we look at the spatial pattern of this hotspot of variability, this is what we see is that the hotspots are located in the peripheral seas along the Alaskan coastline and the Eurasian coastline.
Through collaborations and interviews with Indigenous community members, we seek to identify properties of the local sea ice regime that affect individuals and communities from day to day and year to year. We'll define indices that quantify trends and variability in these properties by using satellite observations and available local ground observations. Initial indices we're investigating include false freeze-up events in the fall, false breakup events in the spring, as well as plania frequency and duration. We aim to produce observational analyses that not only inform the ARC-NAV team's predictive modeling, but especially support local level decision-making processes.
Leslie Hobson, the administrative manager for the AEWC, how they view this collaboration.
The AEWC appreciates the work being done through this project to track changes in our meeting agendas over the life of our organization. For example, who comes to our meetings and the issues we have engaged with. We believe this work will help us show how the AEWC has grown as a regional co-management body during its 40 years of work to protect the bowhead whale and the rights of our whaling captains.